What's happening, dogs? Mr. Allen here with some evaluation of trig functions using our sum and difference formulas. So oftentimes you'll come across some of these weird angles that aren't your nice, 30, 45, or 60 degree reference, or pi over 6, pi over 4, pi over 3 reference if you're in radians, but you're asked to evaluate them, and you need a special formula to do so. In these ones, we're going to use the sum and or difference formulas pending the angle that we're working with. In this first one here, I've got 15 degrees. I got to find two angles that have a sum of 15 degrees or a difference of 15 degrees. I'm thinking difference on this one, and I'm thinking 45 minus 30 would give me that 15 degrees. And I know I can evaluate trig functions with 45 and 30 degree reference angles, all right? First quadrant 2, that's dope. All right, so first thing here, I'm going to write down that this is sine of 45 minus 30. I always like to write down my two angles. I know it's like, I can keep it in my head. It helps, okay? This is my alpha and this is my beta in that formula. Most of the time you'll see this formula written with alpha and beta, okay? So now I got to plug all this into the formula and then do some trig evaluation. Super fun, all right? We got sine of the first angle, which is 45 degrees, times the cosine of my second angle, which is 30, minus, and then you got cosine of the first angle, alpha, which is 45, times sine of the second angle, which is 30. Okay, now I got to do some evaluation, right? I got sine of 45. Your unit circle or special right triangle, however you want to do it at this point, you should be pretty quick with it, right? It's going to be 1 over root 2 if you're a special right triangle. Rationalize, you get root 2 over 2, which those of you using the unit circle might be super quick with that. I'm a triangle guy, though, man. I just remember it. Maybe it's because I teach geometry as well and have for many, many years. All right, cosine of 30. Well, that's going to be what? We got our adjacent root 3 over 2, right? So root 3 over 2. And then we got minus cosine of 45 is root 2 over 2. And then we got sine of 30, that's going to be 1/2. Okay. Now we can do some multiplication. Root 2 times root 3 is root 6. Over 2 times 2 is 4. Right? We're multiplying, so we multiply across. Don't forget your basics when you start going crazy in the math, right? Minus, and then we got root 2 over 4. Excellent. Common denominator, can I add my numerators or subtract, put it all into one fraction rather? Yes, we can. Now, root 6 and root 2 are not like terms, so we're just going to leave it as root 6 minus root 2 over 4. Final answer. Beautiful. Fantastic. Wonderful. You're going to notice with a lot of these, it's going to be combinations of like root 6s, root 2s, and 4s, okay? So you might start seeing these like, is it always like the same answer? They're always very similar answers, but no, it's not going to be the same exact thing every single time, okay? But you will see that a lot. And also, fun fact, if you plugged sine of 15 into your calculator right now, and you plugged this whole mess into your calculator right now, you would get the same answer. Kind of cool. A good way to check yourself. These are going to be non-calc problems on a test most likely, but you can check yourself, to see if you're doing homework right. It's a good idea. Cosine, 7 pi over 12. I'm going to change this to degrees, man. I'm going to change this to degrees. So if I take, I'm going to do a little side math here, 7 pi over 12 times 180 over pi. I'm going to get 105 degrees. Okay, so let's rewrite this. Cosine of 105. I find it easier to do this all in degrees. It's easier to find things that add and subtract with each other. Radians a little difficult with that. So I'd suggest doing a quick conversion to degrees, okay? So you get cosine of 105 degrees. So what two angles would either add or subtract, right? Sum and or difference to that 105. I'm thinking like maybe 60 and 45 would work. Those are nice ones. Also in the first quadrant, so that's like easy to deal with. I don't have to think about positives or negatives, right? So there we go. Let's rewrite that as cosine of 45 plus 60, or you can do 60 plus 45. It really doesn't matter, okay? Now we got to plug this into my sum formula, which is actually subtraction for cosine. So watch out for that. So we're going to have, let's see, equals. Got to keep it all tightly packed here. Cosine of my first angle, 45, times cosine of 60, not 6, 60, minus, and then we got sine of the first and second. So sine of 45, sine of 60. And I know it's a little overwhelming to memorize all these formulas as you're getting them, but look for those little patterns, right? Sine is sine cosine, the subtraction matches up, the addition matches up, and then it's cosine sine. For cosine, it's cosine cosine, but then the adding or subtracting is the opposite of what we have in here, okay? And then it's sine sine. Alrighty. Cosine of 45. We know that's root 2 over 2. Because you're going to be doing these things so frequently that you're just going to be like, oh yeah, I know that one, I know that one, right? Cosine of 60 is 1 over 2. It's the adjacent over the hypotenuse, or use your unit circle. Again, I'm a triangle guy, man. I'm big into triangles. Then we got minus sine of 45. So sine of 45 is root 2 over 2. And then sine of 60 is going to be root 3 over 2. All right. So my first little couple fractions there, root 2 times 1 is root 2. 2 times 2 is 4. Oh my goodness, we're getting the same things. And then we got root 6 here, right, over 4. It's like I just said something about how you're going to get a lot of the same things, but they are different. Check it out. We got root 2 this time minus root 6 over 4. So they are switched spots there. So don't just, I mean, I guess if you're like, shot in the dark, root 2s and 6s. But no, they're probably not going to give you credit if you don't have the work, right? So there we go. Root 2 minus root 6 over 4. Beautiful. So the name of the game here with your sum and difference formula, guys, is that you need to find, your two angles that will either add or subtract to that angle that we're working with. Pro tip, change it to degrees. That's just my opinion there. Some people probably, roll with the radians, but I'm rolling with degrees, okay? There's a few times where I'm going to say convert to degrees instead of using radians, and this would be one of those few times. Easier to see it, I think, with the sum and difference formulas. All right, cool. That's about it here. Hope you guys enjoyed it. Keep watching, because I got more videos coming here with all these different formulas. We got double, half angles coming up as well. So, I mean, some great stuff coming. See you later.